I'm going to start to catch up to you guys. Where was it? 40. The only reason I put this here is so that you had a reference for in the future, just to show you what it looks like when you put it in the calculator, right? So I want 7 San Diegans out of this group to smoke. So I got 44 of them. I want to choose 7. So that means I want 7 of these. So I want how many of these?
37.
So see the formula? It always makes it look worse than it really is. But all that n minus x means is the total minus how many I've got so far. That's how much is left, right? That's the rest. And what do you guys get?
161.
That sounds right. What is it? 16? 1 1? Ooh, we got some dissension. I like it. So let's see. 44. Choose 7. Choose 7. Choose 37. 1611. Yeah. Is that cool? Okay. The probably that none of them smoke, so I got 44 people. I want none of them to smoke, so I got no what we're calling successes. And all of them are over here. So in general, success doesn't have to be a happy thing. If I'm out there looking for rabid squirrels, then a success is a rabid squirrel, right? So success is just what I happen to be looking for. Bless you. So I'm going to do this and get the same answer you guys got. Right? And just real quick, remind me, what is anything to the 0 power? No. 1. Real quick, just because that happened. I know. What's x to the 7th divided by x to the 5th, for example? X to the 2nd, right? Don't you have 7 x's and 5 of them cancel, right? Is that cool? So what is x to the 5th divided by x to the 5th? Well, what's something divided by itself? 1. But what power would you get if you subtracted these? You get x to the? Okay, so anything to the 0 power is 1. Okay. So that's 1. How many ways is there to choose nobody from 44 people? I choose nobody. There's one way to do it. So that's why. Do you have to know what I'm talking about right now? No. You could put this whole damn thing in. It'll still give you what eventually becomes this, right? So just because I know the E thing is going to come up sometimes, because some probabilities can be very tiny, you have to know how to interpret it. Always write it as a real decimal number, right? This is that idea we've been talking about off and on. If I wanted to calculate this directly, I'd have to do the formula for 1, the formula for 2, the formula for 3, all the way up to 44, and then add them all up. That would work. Don't do that. The opposite of at least 1 is none, and I already did the probability of none. So I just have to do 1 minus 0007. James Bond's understudy, I guess. All right. I like it. And then these are, as I promised, every time we have a new way to be given data. So now this binomial, these are called binomial distributions. That's another new way they can give me data. I need to have a way to calculate these two things. And we do. So this will be 44 people times 15.2% of them. 6.688, sorry? Trying to remember, I just did this one yesterday with the other class, so I remember some of these numbers. And then this guy, square root of 44, 152,848. What do you guys get? 3.8. 3.8. Ooh, dissension. I like it. So if I do, now watch, here's what I do. Look what I can do. There's the mean, right? square root of that times Q. So I get 2.381. Is that cool? I don't care about the other shit because standard deviation I have to take it to at least 3 places. I'm lazy, I'll take it to exactly 3. Okay. And this one should sound a little familiar, but the difference here is, now here's the thing. I don't know how many of you guys read this part of chapter 2, because I don't think I talked too much about it. But if I have a normal curve, 68% of stuff is within 1 step away. 95% is within 2 steps away. So how likely is it that something will be more than 2 steps away? Only 5% chance. You guys semi with me, right? 5% chance it's outside. That we call that unusual. That is our current definition of what unusual is. Something that has 5% or less chance of happening. Does that kind of work? Is that all right? You might not pick 5%, but if you wanted to, you're like, sure, that makes sense for what the hell unusual is. Later this semester, we'll actually have more specific ways of identifying what unusual is. For example, if you're working at a nuclear power plant, how close to the red will you let that needle go before you get off your ass to see? It has to just move a little bit towards yellow, and I'm up. You guys with me? So I'm going to call unusual anything close to yellow, right? Which is not 2 standard deviations. I don't know if you guys see what I'm saying, but it's dependent on the situation. But the general rule is inside of 2 standard deviations is usual. Outside is unusual. Kick ass. So I put the mean in the middle, just like we have in the past, but now I'm going to take 2 steps up and 2 steps down. If I take 2 steps up, 11.879. If I take 2 steps down, do it again.
1.926.
Okay. Anyway, all right. So anything in here is usual. I wouldn't be surprised if it happened. So would I be surprised if I saw 15? Yes. It's outside of 2. It would be unusual. It's sort of like, would it be unusual to see somebody 7'7" come in the room? 7'7". Yes, because that is more than 2 steps above the mean height. If somebody 5'9" came in, a dude, would that be unusual? No, that's the freaking average. That's me. If I walked in the room, I'm gonna go, look at that height on that guy. No. He's expected. If you saw somebody 3'7" come in, unusual, because that's below. Okay, enough. Any questions on this thing here? I personally think that's enough. What do you guys think for today? Anybody feel gypped if I stop here? I have had people get annoyed at me because I let them out early a few times. I was like, holy crap, get away from me. Okay, so I'll see you guys next week. We'll do that quiz.